We're almost there. Last week, next Monday is finals. Chapter 10 is on the conic sections. I think it's easiest just to show you the conic sections with the printout that comes with the book, because, oh shit, wrong button. Let's do this. So you literally have like an hourglass shape. And parabolas come from just doing slicing through the one side of the hourglass. So parabola is that shape right there. Ellipses is when you slice through a whole cone but at an angle. If you slice flat through the cone, you get a circle. You slice through at an angle, you get an ellipse. And then if you slice vertically, you get something called a hyperbola. These are called the conic sections in general. And they actually do a lot of stuff, even outside of geometry, that the equations that they create are used in differential equations, all sorts of stuff. So 10.1 is on the parabola. Let's try spelling it right. You've seen this, y equals x squared. That is our generic parabola. You go right one, you go up one. Same thing with to the left. You go right two, you go up four. So 2, 4, 1, 1. And the same thing works on the left. -1, 1. -2, 4. That's your standard parabola. Your basic, no frills, nothing sexy about it. Then we learned how to upgrade it some. We learned how to do y equals a times x minus h squared plus k. Where it shifts this point here, the vertex is at hk. Another way of writing this is if I subtract k from both sides, I would get y minus k equals a times x minus h squared. These two are the same. A greater than 0 opens up. A less than 0 opens down. Now we're going to change it up. That's the old shit. Let's do some new stuff. So here we had y minus k equals a times x minus h squared. What if we had x minus h equals a times y minus k squared? The square is on y now. It still has a vertex at hk. But since y is squared and not x, when x was squared, we opened upwards in the positive y direction. When y is squared, we open in the positive x direction. It goes to the right. That is x equals y squared. Here we've got when we would move right. It used to be when we moved plus or minus 1 in the x, we'd go plus or minus 1 in y. Nope, not plus or minus 1 in y, plus 1 in y. Plus or minus 2 in x, we'd go plus 4 in y. Here, it's the other way around. If we go plus or minus 1 in y, we go right 1 on x. We go plus or minus 2 on y. We go right 4 on x. Plus or minus 3, we go 9 on x. So whatever the y value is, we square it, and that's our x value. It's a parabola opening to the right. It opens to the right. If a is greater than 0, it goes to the right. If a is less than 0, it opens to the left. So let's graph a couple. We're going to do x minus 4 equals negative y plus 2 squared. So where is our vertex? 4 and 2. In which direction does it open? Left. Opens to the left. The negative says it opens to the left. And from there, we can do a is 1. There's no more scaling on it. So we go up or down 1, left 1. Up or down 2, left 4. So we're still on our first page, Eric. Okay. Parabolas, we did all this shit before. X was squared here, now we're doing y squared. That's all that's changed. Let's start a more fun one. It has a little bit of completing the square in it, because that's how I roll. Now, we can find the exact formula for this in that format up here if we complete the square. So completing the square in this regard means factoring out the 1/2. And we're gonna have y squared minus 8y. And then I'm gonna leave a blank and I'm gonna have my +6 over here. So just like we've done in the past, we take this, we cut it in half, and we square it. I'm adding 16 in here. Adding 16 in there means overall, we've added 1/2 times 16, which is 8. And if I've added 8 to the right side, I need to subtract 8 from the right side to keep it in balance. Or alternatively, you could do the +8 over here. Add 8 to both sides. But to get x where we want it over there, I'm going to put the 8 back over. So I've got x equals 1/2. This turns into, just like we did with the completing the square on the other stuff, that number comes down and we got squared. And then I had +6 minus 8 is -2. So if I want it in the form up there, I'll add the 2 back over. X plus 2 equals 1/2 y minus 4 squared. Are we good with that? Luis doesn't look good with this. Need a little time to process. So you take that, you cut it in half, and you square it. We're making this a squared thing like this. You'll notice if you multiply this back out. We get that. So to do the complete the square thing, we need a 16 in there. But this whole thing had a 1/2 on it for the y squared. We want y squared to be 1. I mean, I could have multiplied through by 2 and then maybe divided by 2 later.
What if it was like, instead of 1/2, we use instead of 1?
It was 1, we wouldn't have, it would have just been +16 and then -16. So whatever's on the outside, that's what we're effectively adding to the side. We're adding 1/2 times the 16. Because this didn't, just like this is multiplied by this. So even though it says 16, we technically only added 8. Another way that might make this a little bit more pleasant for you to get to the same spot. First off, get rid of the fraction. Multiply through by 2 on everything. Now you can complete the square here normally. And we add 16, so I'll add 16 over here. So 2x plus 16 equals y minus 4 squared plus 12. Subtract the 12 over. And then divide both sides by 2. We don't want x to have a number in front of it. So x plus 2 equals 1/2 y minus 4 squared.
Don't want to do it.
What?
Getting rid of the fraction.
You like that better?
It's just adding 16 and adding another 8. It just seems like you just pull it out of number. It seemed like
Well, the 16 is to complete the square.
yeah, but the 8 was just like, why the hell did you pull that out?
Because I didn't really add 16. It's got a multiplier on it. So even though the 16, it says 16. If I were to multiply this out. That's 1/2 y squared minus 4y plus 8. So I really only added the 8, so I need to do the 8, subtract the 8.
That's just.
So how would I graph this? Well, first off, what's our vertex? What is it?
2 4.
Close. It's like -2 and 4. Working with that 1/2 to me is a pain in the ass. So what I like to do is find the intercepts. When y equals 0, what does x equal? X equals, the one original equation was 1/2 y squared minus 4y plus 6. So when y equals 0, x just equals 6. So 6, 0 is a point on the graph. Then I could do what about when x equals 0? When x equals 0, I've got 1/2 y squared minus 4y plus 16 or 6 equals 0. If you multiply through by the 2, you said you liked that. That looks like y minus 6 and y minus 2. So we get y equals 2 or y equals 6. Along with the x. So I got 0, 2 and 0, 6.
Put it down a bit. Or it's good.
Ready for some more? Let's look at that graph. So where's some points we got? We've got -2, 4. That's my vertex. We've got 0, 2 and 0, 6. And we had 6, 0. We know the parabola is like a perfect reflection of itself. It's across something called the axis of symmetry. this is the axis of symmetry. It goes right through the vertex and down the middle of the parabola. So like, I know it's going that way from the vertex because my points are over here. If I want to fill in the rest, I can actually use symmetry, this reflection thing, to figure out a point up here fairly easy. Here, I am right 6 and I am down 4 from this line. So if I go up 4 from the line, this is down 4. I'm going to go up 4. And fill in the other point. How's that for some fucking magic? Interestingly enough, we haven't mentioned the definition of the parabola yet. So the definition of a parabola, this is gonna bake your noodle until we draw a picture. Parabola is a set of all points in a plane. It's a two-dimensional surface. Equidistant from a fixed point. And a fixed line. Fixed point is called focus. And I fucking love the name of the fixed line. It's called the directrix. It's a fucking pimp name. It's actually really, really close to the definition of another shape you know really well. If I said the set of points in a plane equidistant from a fixed point, what shape does that describe? So you got a fixed point, and you go out the same distance. Circle. The addition of the line changes it to something different. So what does that look like? The easiest way, the only way I'm gonna do this focus and make it look right is if I give you the equation right away. If we do x squared equals 4py. E is the distance to the focus. And the line from the vertex. So if I have y equals x squared, then 4p equals 1, and p equals 1/4. My focus is right down there. And my directrix is right there at 1/4. Probably not the best way to show it. Let me pick a different value. Let's do p equals 1. When p equals 1, we have x squared equals 4y, or y equals 1/4 x squared. Maybe grabbing this will make it look a little bit better. So when x equals 1, y equals 1/4, really small. I need to cut that in half and then half again. So when x equals 1, y equals 1/4. And when x equals 2, x squared is 4 times 1/4 is 1. So my parabola is really wide now. Focus is at a distance p. My focus is there at 0, 1. The directrix is a distance p the other way. This is a little bit easier to see.
Can you go a little bit up, please?
The other graph isn't going to help you that much. It's too small.
Okay.
That's why I did a bigger one.
So is the first point 1 and 1/4?
So this, say that, what's the question?
1/4? Yeah, the 2 points are right.
So the points here are, our focus is right here. Focus is at 0, 1. It's up p from the vertex. Directrix is down 1. This is y equals -1. It's a line. the overall equation is x squared equals 4py. So I deliberately picked p to equal 1, so I could have a little bit more space to graph it for you. Normally, you don't pick p. P just is, you have to calculate p. And we'll go over some problems doing that. So like p is like a distance, and the way it works, check this out. Like that I said it's equidistant from a fixed point and a fixed line. The way that works is, let's say we're here, the point's here. The distance here and the distance straight down here are the same. And it doesn't matter which point I go to. Let's call that D1. If I go here, D2, that distance is D2. Headlights are parabolic. The light bulb or the headlamp, I believe, is the official word for a light bulb in that headlight. The headlamp is at the focus. So that when the light hits it, light emits from the bulb. No matter which way it's going, it reflects the same direction. So the light all goes in one direction. Interesting, well, because the metal, it's shiny metal, it's reflective. Light hits it, it's all reflective in the direction. So x squared equals 4py. Is for up and down parabolas. If you have y squared equals 4px, now you're looking at left and right parabolas. Again, p is the distance from the vertex. Let's say along the axis of symmetry. So let's give you guys some problems to do together. So for the problem we're going to do, give the focus. Rectrix. Vertex. And axis of symmetry. And then graph it. Those are our instructions. Problem 1, we're gonna do x squared equals negative 4py. Nope. Close to what I wanted to say. X squared equals negative 4y. So the way you go about doing this is compare this to negative 4py. And you'll see that negative 4 from the equation has to equal negative 4p from the formula. Our coefficients have to match up. And so what does that mean? P's got to equal 1. Divide both sides by negative 4 and you get p equals 1. So x squared equals negative 4y might be a hard way to picture what's going on. If you solve for y though, we get y equals negative 1/4 x squared. These two are the same thing. I just divided by the negative 4. What is the shape of this? It's which direction does it open? Opens down because it's negative. So it opens down. The vertex, we don't have an H or a K here. So the vertex is 0. Well, 0, 0. And that, knowing which direction it opens, kind of helps us use the P a little bit. That means the P is down 1 here to get to the focus. So the focus has to be at 0, negative 1. And we're going to go 1 the other direction to get to the directrix. That's got to be the line y equals 1. So we have the focus, we have the directrix, we have the vertex. I was a little sloppy with the graph. If we had like you put it on axes and with like hash marks and stuff to see a little bit better, we could like make sure the points are lined up well. What is the axis of symmetry here?
That should be x
The
0.
y-axis. It's the
X0.
y-axis, and which is x equals 0.
Yeah.
So it's along this. Now I want you guys to do the same thing for y squared equals 12x. Now that we walk through one together, Give it a gander yourself. We'll do it together in a couple minutes.
Antes de que se me acerque un reggaetonero y me diga, oye, ya tú sabes, y que yo no sepa.
Okay, so if we treat this like where it goes, the 4p goes on the variable that doesn't have an exponent. So we're gonna compare this to y squared equals 4px. Which means 4p equals 12. And thus p equals 3. If I were to solve this for x, I would have x equals 1 over 12 y squared. Which is a parabola that opens which direction? goes to the right. It's going to the right. Which means the axis of symmetry is this is the y-axis, that's the x.
The x-axis.
So the axis of symmetry is going to be the x-axis. E is 3. We're gonna go 1, 2, 3. Directrix is 3 the other way. So my focus looks like it's at 3, 0. And my directrix, what is that line? What? Well, that point's -3, 0, but what's the line? What is -3?
The directions.
We gotta have a variable with it, is what I mean. Is this an x equals or a y equals?
It's an x equal.
It's an x equals. All the values along this line have the same x.
Be safe to say that A equals the focus.
It's the distance to the focus.
It would be in between, right? Like from.
So P is that length right there.
Okay.
And I guess we could find some values, but I know it opens to the right. And I'm guessing that 1/12 makes it fucking wide. But it's probably not wide enough. If we had an actual something to graph with well, we do it well. Let's take a 5-minute break because I know Josue's got to go to the bathroom.
Yeah, I need to do that.
All right, let's kick it up a notch. Let's find. Here, let's do this. Write an equation. For each parabola with the vertex at the origin. And question number 1, we're going to have the focus is at 0 3/4. So the way I'd go about this is I would draw a little picture. I know my vertex is there. It says my focus is up at 0 3/4, which means the parabola is opening upward, which means this is going to be an x squared one. Which means we have x squared equals 4py. And we can use our focus. Our focus is up 3/4. That's got to be our distance p. So x squared equals 4 times 3/4 times y. And so I end up with x squared equals 3y, or y equals 1/3 x squared. You know what else has a parabolic shape? Satellite dishes. The transmitter receiver is at the focus. And so when it's transmitting, it radiates all directions, so sometimes it just goes straight out. But anything that emits and goes back to the dish, all gets reflected one direction. And then all the transmissions coming in, they hit the dish and they reflect and all hit the focus. So all the transmission lines coming in reflect, no matter what angle or where they're coming in from, they reflect and hit the focus, which is where the receiver would be, and so that's how satellite dishes work. Let's kick this up a notch. Now that everybody presumably has that one written down. B, we're gonna change a little bit. We're gonna say it has a horizontal axis of symmetry. And the parabola passes through the point -4, -8. Now, first thing tells me that's my axis of symmetry. It's a horizontal one, which means we either have one that opens to the left or something that opens to the right. We don't know which one yet. The fact that it's going through -4, -8 makes me think it's opening to the left. This one, that's the shape where we have a y squared. Y squared equals 4px. So we'll start with that. And now we gotta use our other information. We don't have, they didn't give us p. But they did give us an x value that's on the line. That value is on the line, let's plug it in. So -x squared is 64. This is -16. So p equals -4. Which is makes me want to amend what I said earlier. When I said p is the distance from the point, the absolute value of p is the distance from the vertex. Because p can be negative and distance cannot. So I've got p equals -4. I'm gonna take it, I'm gonna plug it in, and I get y squared equals -16x. Or alternatively, x equals -1/16 y squared. Now, those are the equations. X squared equals 4py and y squared equals 4px. These have a vertex at 0, 0. Let's upgrade. X minus h squared equals 4p times y minus k. And y minus k squared equals 4p times x minus h. Those are our upgrades with a vertex at hk. So let's find the equation for a parabola. With a vertex -2, 3 and a focus at -2, 2. Well, maybe a little quick sketch will help. That's my vertex. And my focus is one below it. Which means we're going downward. Which means this is an x squared one. So this is in the form x minus h squared equals 4p times y minus k. What's p here? Looks like a 1, right?
Yeah.
That distance right there, that's my distance p, it looks like 1. So we've got p equals 1 and we have our vertex. Let's just plug in our shit. X minus -2 turns into x plus 2. 4p is 4 times 1 is 4. Y minus k is y minus 3. Alright, that'll be it for parabolas. Let's take a look at ellipses. We're gonna start 10.2, but we're not gonna finish it today. 10.2 and 10.3 are very similar in content, and yet graphically, they look nothing alike. Which is crazy. 10.2 is on ellipses. Let me spell that where it looks a little bit easier to read. Ellipses. An ellipse is the set of points in a plane. We start off with a similar definition as the other one. And we do talk about distance in the definition. But here it's the set of points in a plane, the sum of whose distances from two fixed points is constant. Each one of these is a focus point. The plural of focus is foci. That's the plural. So we have a couple ways this goes. We can have a wide ellipse. Or we can have a tall ellipse. The longer it is, I don't know where the focus is, but. So when we say the set of points in a plane, the sum of whose distance from two fixed points is a constant, you pick any point on the ring. Let's call that D1 and D2. D1 plus D2 equals some constant number, no matter which point we pick. I could be way over here and have D1 be really long and D2 becomes really short. In both of these, I'm going to say that this goes a distance A out on the x-axis and a distance B out on the y-axis. And the foci here. On the left one are at negative C0 and positive C0. Over here is 0 C and 0 negative C. You look at the notes that like you look at the multimedia library and shit, they got some fucking confusing way of like, they change the formula for each one, they make it all fucking backwards. For one of them, they say all of a sudden we're gonna use B with X and no. They do it all to make C consistent. The easiest way to do this is say C squared equals the absolute value of A squared minus B squared. The book will mix around X and A and Y and B to try to make this A squared minus B squared or B squared minus A squared. But if you just do C squared equals A squared minus B squared and do the absolute value, you can find the distance to the focus right away. And the general shape of all of these parabolas is x squared over a squared plus y squared over b squared equals 1. So the long axis is called the major axis. And the short side, shorter one, is minor axis. The ellipses look like ovals. So let's look at some examples. Four x squared plus 25y squared equals 100. We usually don't write the ellipses with fractions. Same thing goes with hyperbolas, which we'll do on Wednesday. We don't write them as fractions, we clear the fractions. Which means if we want to write them in a form that makes it easy to find the ellipse, we got to convert it back to a fraction by making the right side equal 1. You divide and so such that the right side equals 1. If you do that, the 4 goes into 100 25 times, and you're left with 25 on bottom. Because 100 is 4 times 25. And the y squared, the 25 on bottom will cancel, and we're left with a 4. Now, match this up with x squared over a squared plus y squared over b squared equals 1. What does a equal and what does b equal?
Base 25 to 25.
A squared is 25, B squared is 4. So if you want A, you gotta take the square root. A equals 5, B equals 2. That C we were talking about. C squared is the absolute value of A squared minus B squared, which is the absolute value of 25 minus 4, which is 21. So C squared equals 21. So C is the square root of 21. Which is about, I don't know, 4.55 maybe. I don't know, I'm estimating here. It's a little above halfway between 4 and 5. So we're gonna graph it. I need to go out A along the x-axis, which is 5 in each direction. And you know what? Maybe I'll make these bigger. Each of my little hashtags is a half. So this will be 5. -5, 0. 2, 0 up here. -2, nope, 0, 2 up there. And 0, -2 down here. Just gonna connect them and put a little curve at the end. Don't make it look like a fucking diamond. If it's a diamond, it's wrong. And our foci is along the major axis. Foci is along major axis, COA. See away from center. So like right about there. Maybe F2 and F1's way over here. You guys ready to try one? I see y'all still writing. When you are, your next one will be 49x squared plus 9y squared equals 441. You guys ready to take a look at it? How are you guys doing? Done? Luis, done? Roberto? Still working on it? Okay. Well, let's take the, we want to divide this by 441. And conveniently, 49 times 9 is 441. So this should reduce to x squared over 9 plus y squared over 49 equals 1. So what does that tell me about A and B? A is what? A is 3 and B is 7. Remember, this is A squared, B squared. So, if we're drawing it, looks like this is one of the tall ones. So we're gonna go up and down 7, left and right 3. B squared is the absolute value of A squared minus B squared, which is the absolute value of 9 minus 49. C squared equals 40. Which means C is square root of 40. 36 would be 6, 49 would be 7. This is closer to 6 than 7. I'm gonna guess maybe 6.35 or something like that.
3.32.
32? Not a bad guess.
Yeah.
I'm always gonna guess to like the half, that 5 in there somewhere. 32 is, that's just be, there's no way I'm gonna guess that. So, way the fuck out here. So F1, F2. We're gonna do some more problems with this. The general format, that's with the center at 0, 0. Centered at HK. X minus h squared over a squared plus y minus k squared over b squared equals 1. We're definitely going to do some more with this tomorrow. I want to start you on a hard one now, like the hardest one that you're going to really do. Because we're going to have one on the exam. And so if I do it today and I do it again on Wednesday, you'll get a twofer. Because generally, we don't start with it looking all pretty. Throwing in the h and the k when you clear fractions makes it look like something in the form where if you gather all the constants together, you're going to have like an ax squared plus a by squared plus a cx plus a dy. And like when you multiply this out, there's going to be like h squared over a squared is a constant. K squared over b squared is a constant. We add it to the other side, there's an e in here as well. And if a and b are not one, like notice the coefficients haven't been 1. They're not gonna be 1 down here, which means we get to complete the square. So let's just look at an example. 4x squared plus 9y squared minus 48x plus 72y plus 144 equals 0. Okay, first thing you do, put all your x's together and all your y's together. Maybe move that to the other side. So I'm gonna have 4x squared minus 48x plus 9y squared plus 72y equals negative 144.
Sorry, I was doing something here because I was behind. So you mentioned something about like not doing it, not like you're not gonna do it right now because we're gonna what? You talk about like the ellipses, or I don't know what you talk about.
We're doing, I'm gonna go do more stuff with the general form here.
Yeah.
We're starting with the hardest version of it, where you have to complete the square.
Okay.
Okay. We don't like having the numbers in front, so I'm gonna factor those out. And leave a space. Do the x's together and the y's together. If I complete the square here, I divide that and square it. I'm gonna have a 4 times x minus 6 squared there. Here, I cut that one in half, square it, and I get plus 16. I'm gonna have a y plus 4 squared there. And now this is the part that y'all aren't gonna like. Luis already said he didn't like it when we did it with a single one. We added 36 here, but the 36 is multiplied by 4. So we added 4 times 36 on the left, we've got to add 4 times 36 on the right. Okay. Doing the same thing here, we didn't just add 16, we added 9 times 16. Now, I don't know what those are. I think 4 times 36 is 144, isn't it? 72 doubled?
Yeah.
So I've got negative 144 plus 144. Oh shit, plus another 144. 90 and 54 is 144. We end up with a positive 144 on the right side. So we did 9 times 16 and 4 times 36. That's why I'm doing this today. I'm gonna do it again on Wednesday. Now we can divide by the 144. We want to get this right side. It just so happens to be positive 144. Generally, it is not the. You have to do the actual math and find out what it is. The fact that it's the opposite sign of what was there before is a coincidence. Okay. I don't know what that simplifies down to. This is 1/36. And 16 there. So what's our center at? And what's our A and what's our B?
A is 6.
A is 6. 4. Where's the center? 6 and -4. It's the opposite signs of what we see. All right, so God's way over here, right 6 and down 4. And we're gonna have to go right another 6. Well, let's see that. My line was all fucking curvy. Look like shit. So it's here rather than doing it. It's easier just to count 6 left and right. Up 4 should put me on the axis there. Down 4 should put me on the axis, or right there. So C squared is the absolute value of A squared minus B squared. Absolute value of 36 minus 16. C squared equals 20. So C is the square root of 20. The foci are moved from the center. It is plus or minus square root of 20 from here. So if you're gonna give them a point, it is 6 plus square root of 20 comma -4. And 6 minus square root of 20 comma -4. What's wrong, Luis? You what?
So it's 8 and then 12.
Yeah. So the major axis has a length of 12 here. And minor axis is 8. And we'll call that a wrap for today. Once you get used to doing the whole, well, we've done completing the square before, but it was no one's favorite. And now we gotta do a little bit more. Once you get past that, it's the same shit as a regular ellipse. Hyperbola has the same issues.